Hi, this is Mrs. McTaggart. This is going to be a long video, so heads up. This is my aim for this is like, I think the night before the exam, the night before the test, you just want to have a quick recap of all the quadratic stuff. It is such a huge part of the National 5 course and it's really important, particularly if you're going into higher. So it's a great video to watch before you start quadratic theory at higher. I just want to brush up on your Nat 5 skills, or as I said, if you're cramming the night before a test or an exam. So I'm going to take you through everything a wee bit at a time. This might not be the order you were taught it in. Every time I teach, I think, oh God, should I do it in this order? Should I do it in that? So bear with me. We're going to start with the basics. We've got 25 slides to get through. So here we go. We're going to start. This is your most basic quadratic. This quadratic has your equation y equals x squared. It is a minimum turning point because the turning point is low down. It goes down low and then turns back up. It is a lovely symmetrical shape. What happens though is if I was to draw this upside down, this one is now got the equation y equals negative x squared. Now this same thing happens if you're talking about straight lines or sin and cosine graphs. If you put a negative in front of the equation, it flips upside down. So this is a graph of negative x squared. We talk about that being a maximum turning point because the turning point is up high. And a wee hint that I always use is I think if you are positive, you are smiley, and if you are negative, you're sad. And it makes a smiley face and a sad face. So if you hear me mention smiley faces and sad faces, that's where it comes from. All right. So what happens is there's one wee random question they can throw in sometimes, and they'll give you a very basic quadratic graph, and they'll tell you, oh, this wee graph here has the equation y equals kx squared. And the only bit of information on the whole graph is this coordinate here. And they're asking you to find the value of k. Sometimes the question will say find the equation, and you have to rewrite it once you know what k is. Now in quadratics, a lot of it's about substitution. And the only bit of information you've got is a coordinate. Now please remember any coordinate can be labelled x and y as such. So what we do is into our equation we substitute x and y with these numbers. So where we have y equals kx squared, we replace y with a negative 12. We replace x with the 2. And then we can work that out. So this gives us negative 12 equals 2 squared is 4. So let's rewrite that as 4k. Minus 12 divided by 4 tells us that k is negative 3. Now, I was expecting a negative because this is a negative x squared graph. It's a sad face. So, the final answer is k equals minus 3. If you want to show off, you can write y equals negative 3x squared. And that's what you would do if they were asking for the equation. Y equals negative 3x squared. So that's one wee throwaway question worth 2 marks. Lovely if it comes up and then you remember that, subbing in a coordinate. Right, let's talk about that original graph. Once we start moving it around, the equation changes slightly. So please remember, this was my original graph here, y equals x squared. Now, if I start moving that graph to the side, so if I was, oh, I thought I could move my ink pen. I can, watch this. No, I can't. I can. If I was to move that pen over to the side a wee bit, if I move it that direction, it means that the graph is going in the positive direction, and in fact this becomes a negative. So at the moment this blue one I've drawn is the graph of y equals bracket x minus 2 all squared, right? And then what happens is, if I try moving this again, and then move it down 6, this graph becomes negative 6 on the end. So the number in the bracket is the opposite of what's on your turning point. This gets explained a lot more in other wee scenarios, but basically if you solve that equal to 0, so if you put that little bracket equal to 0, you come out with x equals 2. And that is basically getting your line of symmetry. There's a line of symmetry going right down the middle here, through the number 2 on the x-axis. So the equation of that line of symmetry is x equals 2. So the way we teach it, the trick that the kids all like is that, well, if it's gone to positive 2, so if it's moved to positive 2 in that direction, you put a negative 2 in your bracket. So in reverse, on this second one, my graph has moved to negative 3. So in the bracket, we write that as the opposite. So we write x plus 3, all squared. And then this one has then moved up 1. So if I think of the original graph, let me go back and get my blue line again. And ungroup it. If I get my original blue line, why are you not moving from my, here it is. Too many lines going on. Here we go. So there's my original blue line. This has moved 3 to the left, so we've written plus 3 in the bracket. And then it's moved up 1. So the turning point is from the origin has gone 3 to the left, so we write plus 3, and then it's gone up 1, so we write plus 1 on the end. So the equation of this graph, let me take all these drawings away, would be x plus 3 all squared plus 1. Let's look at another 2. This time we've got some sad face ones. So we know because it's a sad face, there's going to be a negative in front of the x squared. So this one starts off as y equals negative x something squared. So let's think of the movement. My turning point has started at 0. It's gone 4 in the negative direction and then down 2. So 4 in the negative direction turns into a positive 4. And then down 2 has got a negative 2 in the end. Here we have another negative graph. So we have negative bracket. But this one has started at the origin and it's gone 3 to the right and then up 7. So 3 to the right would be a negative 3 in the bracket, because if it's going positive, you put in the opposite, you put in a negative, and then it's moved up 7. Alright, now I've mentioned that line of symmetry before as well. The line of symmetry is whatever it goes through, whatever number it goes through on the x coordinate. So my line of symmetry or equation of axis of symmetry here would be x equals negative 4. The axis of symmetry of this one goes right through the number 3, so this one would be x equals 3. If you don't write x equals, it's not an equation, you've just written a random number, so it must be x equals whatever your x coordinate is at the turning point. Right, so look at the next bit. So in general, this is a general formula for a quadratic, and I've written it in a plus or minus because we know it could be either, right? From that, the turning point you can just read off from the equation. So now I'm going to give you the equation and we're going to read off the turning point and the line of symmetry. Now notice that my plus minus has changed to a minus plus. That's because I've been talking about the opposite. If it's a plus 3 in the bracket, it becomes a minus 3, i.e. the opposite sign for the turning point. So let's have a look at some examples. So if I gave you this graph here and asked you for the turning point, we would say, right, okay, first of all, it's a positive x squared. So we have a minimum turning point and it would happen at plus 4, means it's going 4 to the negative direction. So it's the opposite. Why is it not letting me do an arrow? So it's the opposite sign. So it goes to negative 4 and then minus 3 means it goes down 3. If we then want the line of symmetry or the equation of the axis of symmetry, it's x equals whatever you've put in here, so x equals minus 4. Now what they might ask is they might ask you to sketch it. So let's go ahead and sketch it while we're here. So here's my little sketch. I have a smiley face with a turning point of negative 4, negative 3, so down here somewhere. There's one more thing I need to find out. I need to find where this is going to cut the y-axis. So to get your y-intercept, please remember, anything on your y-axis has got an x-coordinate of 0, so it's 0 something. So if you plug 0 into your original equation, you will have 0 plus 4, all squared, and then take away 3. So 0 plus 4 is 4, squared is 16, 16 take away 3 is 13. So when I draw this, it needs to have a positive y-intercept, so wish me luck. There we go, this looks not bad. Sometimes I'd have to rub this out and draw it again. So there is my quadratic. This is cutting at the number 13. And my turning point is at, what did we say? Minus 4, minus 3. I just watched right in there, my y-intercept was 0, 13. So if you're sketching it, that's all the stuff thereafter. Let's do another one of those ones. So if we had to sketch this one, we've got y equals x minus 2, all squared. So our turning point is the opposite of minus 2, so this will be positive 2. And then plus 4 means it's gone up 4. It is a positive x squared, so it's actually a minimum turning point again. And then we want the line of symmetry, just in case it asked for it. So the line of symmetry is x equals, whatever you wrote for your x coordinate, so x equals 2. Let's go get the y-intercept. So the y-intercept we know is 0 something, so we're going to plug in 0. So we'll have 0 take away 2, square it, add on 4. 0 take away 2 is negative 2, square it is 4, add on 4 is 8. So when I draw this one, turning point of 2, 4, let's say that's over there. Positive y-intercept. That looks okay, I'll go with that one. So y-intercept 8 and turning point of 2, 4. Really, I should be labelling my x and y axes as well. So, next up we have a couple of exam style questions based on this kind of format. So these are all in what's called completing the square form. I'm going to show you how to complete the square in a wee minute or two on one of the next slides. Okay, so here is a graph. We are told the equation up here in a general kind of form. And we are told the turning point. So these are our points of interest. So what I'm going to do is I'm going to shove that turning point into the equation. So it's gone to positive 4, so that will be negative 4 in the bracket. So x minus 4 all squared. And then it's moved up 1, so plus 1. So here is my new equation. Underneath that, I'm just going to rewrite my other equation that they gave us originally. So I'm going to write that that was x plus a all squared plus b. Okay, so for part A, it's asking me, so it didn't ask me to work out the equation, but you know what, it really helps to get the other bits. So it says state the value of A. Now, just by sheer comparison, here is my 2A values. Notice that the A has been replaced with a 4, but the sign has also changed. So in this case, that means that A equals negative 4. Had that been a minus in your original equation, you would have had a minus 4 compared to a minus A, so A would have just been 4, but the difference in sign means that you have a negative. And then B is just whatever's in the end. B is plus 1, so just B equals 1. So there's your answers to part A and part B. Part C is the wee twist of the question. It says P is the point 0, C, find the value of C. Well, P is your y-intercept. They're just asking you to get your y-intercept. So we know that it's 0 something, so we need to plug in x is 0. So we're going to do y equals 0 take away 4 all squared, and then we're going to add on 1. So we really needed this equation written out anyway for this part. Let's plug this in. 0 take away 4 is minus 4 squared, it's 16. 16 add 1 is 17. So it's not y in this case actually, it's c equals 17 for your final answer. Here is another similar one. What I don't like about this one is the layout. Look at this formula. This looks really weird. So do you know what you do? We rearrange this and we write it the way you're used to. There is a minus in front of the bracket because look at this shape. We've got a sad face. So it's negative x plus a all squared. And I'm just going to put the positive b at the end. Now it looks how we're used to. So let's go with this. State the value of a. So what I'm going to do is I'm going to write in my coordinate. So plus 5. It's gone to positive 5. So that becomes negative 5 in the bracket. So x minus 5 all squared. And then it's gone up 12. So there's my equation. State the value of A. Here's another one. Look at this. I've done it again. The A is compared to a negative 5. There's a change of sign going on. So A is negative 5. Then it asks for B. B is the number. B is just 12. And that's that for that one. Okay, so watch out for that kind of different format. In maths, it's not really nice to start with a negative x squared, so quite often you'll see them jumbling up the order. Okay, so let's go back and recap how to complete the square. So you need to be able to complete the square sometimes to be able to do all what I've just done in those previous questions. Sometimes all you do is complete the square and write down the turning point, or complete the square and then write down the the equation of the axis of symmetry. So here is your method. It's pretty straightforward actually if you remember how to do it. The buzzword or the clue for this question is when you see this bit here, writing it in this form, sometimes that's got different letters to P's and Q's, sometimes it's A's and B's. But the minute you see that, you're like, oh, that's that completing the square thing. So your tip is this. Step 1, you half the x term. So we're going to half the 6. So this becomes y equals x plus half of 6 is 3. All squared. So there we've half the x term. Step 2, subtract that value squared. So 3 squared is 9, so you subtract 9. And then you add on this wee plus 4 that was already there. And then that's step 2 done. And then step 3 is you tidy this up. So we've got x plus 3 all squared, take away 5. So there it is and completed the square form. If they asked you for the turning point, let's go for it. Turning point would then be the opposite of plus 3 is minus 3 minus 5. If they asked you for the equation of the line of symmetry, it would be x equals, whatever you put for your x coordinate, x equals 3. Alright, now let's explain. You don't really need to understand fully why we do this. Some people just like to accept the process. But the reason we take away 9 is if I gave you the brackets x plus 3 squared, well, you know that just means x plus 3 written out twice. And if you were to multiply that out, you would get x squared plus 3x plus 3x. In fact, let's just tidy that up just now to 6x to speed up some things. So that's 6x. And then you would get a plus 9. If you look at this equation here compared to your starting equation, what do we need to do to get from that 9 to the 4? Oh, wait a minute, we need to take away 5. That's why your answer ends up with a take away 5. What we do is we get you to do a take away 9 to counteract whatever you get when you multiply out your end term, or whatever you get when you square the 3. You're counteracting that because it's going to be a positive number. Minus 3 squared is 9, 3 squared is 9. So it's always take away or subtract that value squared. And then you get your take away 5. And that they would cancel out and it takes it back to the beginning. Let's do another one. Okay, so same again, y equals x. Now whatever sign is there goes with it. So it's x minus, half of 8 is 4. So it's x minus 4 all squared. Easiest mark in the whole exam. Take away that number squared, so take away 16 and then shove on the minus 3 that was already there. Tidy this up, we have x minus 4 all squared minus 19. If they want your turning point is opposite signs, so 4, take away 19. If they want your line of symmetry, the line of symmetry is x equals 4. If they want your y-intercept, now here's the interesting bit. If they want the y-intercept, you plug in x as 0, right? Which will give you 0 minus 4 all squared minus 19, which will give you 16 minus 19, which will give you minus 3. Now, there is a minus 3 at the end of the equation. The y-intercept is the end term when it's all multiplied out. Please remember, at the end of a straight line, the y-intercept is a number at the end. It's the same with a quadratic. As long as it's all multiplied out, do not think that the y-intercept is minus 19. That's part of your turning point. They can't be the same. So I'll mention more of that in another slide. Good news is we're halfway there. This is slide 12 of 25. Right, so we've done completing the square. What comes next? Right, well, what comes next is we have to look at it in the other format. So we've looked at it in the completing the square format. Now we're going to look at it in like trinomial or just plain old straight out quadratic format. So let's chat about roots. We've not chatted about roots yet. Not the roots in here, but the roots of a quadratic equation. Y-intercept we've already met. The y-intercept is this little thing here. It is your C value, like I just mentioned on the last slide. The roots are where it cuts the x-axis. And then the turning point actually falls in the middle of the roots. So we're going to meet a new way to get the turning point. I showed you how to get the turning point by completing the square. You can also get the turning point by finding the middle of these roots. So for example, if those roots were at the numbers 1 and 3, the turning point would be in the middle. So turning point would be 2 something, and then we'd have an x value to then plug in. Let's go look at some examples. Let me change my pen colour as well. So here we go. Find the roots of this equation. So I've got a couple of questions coming up and they're all literally the exact same method, but they're all worded differently and given them different. So here's a little picture of a quadratic. Here is your quadratic up here. They're asking for the roots. So the roots are here, which are both going to be something 0. So roots occur when y equals to 0. So first thing to do is you put your quadratic equal to 0. And then we're going to factorise in whichever method presents. Please remember, difference of two squares, common factor, trinomial. We're looking for numbers that multiply to 8 and add to 6. Well, it must be a 4 and a 2. Everything is going to be positive, plus 4 plus 2. And then what you do is you solve each of these equal to 0. You'll get really good at these and not have to write this out all the time. Solve both of those. That gives you x equals minus 4. And this gives you x equals minus 2. Now that kind of matches my picture. There's the minus 4. Oops, I nearly wrote minus 2 there. And there is the minus 2. Okay? So that's you. You've found your roots. Alright? So the reason we factorise is to get those roots of the equation. Now if I was going for a turning point would be in the middle there at minus 3. But we'll look at that in another one. Same question again. It's just not got a picture. It doesn't mention roots. But it does say solve. And it's got a trinomial. The minute you see that equals 0... means you go that step further from factorising. So watch the question. If this just said factorise your trinomial, you would just leave it as brackets. If it says solve and has equals 0, you have to go that step further and actually get values for x. So it's a trinomial again, so we're looking for 2 brackets, x and x. We're looking for numbers that multiply to minus 14 and add to minus 5. So numbers that multiply to minus 14 is something to do with 7 and a 2. To get minus 5, it's going to be plus 2 and take away 7. And then we do the exact same again. You put them into two little equations. X minus 7 equals 0. X plus 2 equals 0. And when you solve them, you get x equals positive 7, x equals negative 2. And what you've just done is you found the roots of a nice smiley face equation, and you find that the roots are at -2 and 7. Big part of higher being able to do that like within seconds, so get good at them, okay? So that was a trinomial. Let's have a look at another scenario. This one is not a trinomial, so how can we factorise this one? Now there's two ways you need to be extra careful, right? We're going to factorising hats on, so this is a difference of two squares. This would be written as square root of 16 is 4, so this can be written as x minus 4 and x plus 4. And then we're going to break them up. X minus 4 equals 0, x plus 4 equals 0. So you get the answers x equals 4 and x equals minus 4. However, you might be looking going, why doesn't she just take that number over? We can do it the other way. We can just go, okay, take the minus 16 over and it becomes x squared equals 16. X is then the square root of 16. X is 4. Well, hold up, wait a minute. I've only got one answer. I don't like this method. I really don't like it because you run the risk of not getting the marks. There should normally, not always, be 2 roots. If you do this method, you only get one answer. So what you have to remember is when you square root 16, there's actually 2 possible answers. Go way back to first year when you were learning to all your integer work. -4 times -4 is also 16. So the square root of 16 can be plus or minus 4. You can also just write that as 4 or minus 4 that way if you preferred, right? There should be 2 answers normally. So watch out for that one. This is why I don't like that method. If we're factorising, let's be honest, we should be doing difference of two squares. Okay. Next one, we're going to go sketch a quadratic, all right? So it's given to us in this form. Luckily, I'll be honest, the times this has come up in the exam, it's already been factorised for you. But look at all the things they want. They want the points of intersection with the x-axis, so they want the roots. They want where it cuts the y-axis, so they want the y-intercept. And they want the turning point, okay? I'm not necessarily going to do it in that order, but that's what they're after. So the first thing we're doing is going to get the roots. So the roots are when your trinomial equals 0. So let's put this equal to 0. My writing is atrocious here, I do apologise. 2 brackets, numbers that multiply to 8 and add to 2. It's got to be a 4 and a 2. To get positive 2, it was plus 4, take away 2. Solve both of these, you get x plus 4 equals 0. You get x minus 2 equals 0. I'm just tight for space now. This gives us x equals minus 4. And this gives us x equals 2. So I have a smiley face with roots at 2 and minus 4. So something like that, right? I'm going to go get my y-intercept just now. There's a long way and a short way to do this. Your y-intercept is when x is 0. You can plug 0 back into this equation up here and go 0 squared plus 2 times 0, take away 8. Or you can remember what I said to you. The y-intercept is the end value. So the y-intercept is minus 8. So our y-intercept is 0 minus 8. Right, so I've got my picture drawn. So my y-intercept is going to be negative. You might want to draw all in different order from me. You might want to wait till you've got all the info and then draw it. Last thing to do is the turning point. So we could go complete the square and do x plus half of 2 is 1. Take away 1, take away 8, and this will give us x plus 1 all squared, take away 9. And then you can say, oh, my turning point is -1, -9. Or, what might be easier now is what's bang in the middle of 2 and minus 4? Well, in the middle of 2 and minus 4, you've got 2 options. This is a jump of 6. Half of 6 is 3. 3 away from each number here gives us -1. So you could say, right, my turning point is when x equals -1. Plug that into the equation. Y equals -1 squared plus 2 times -1 minus 8, which gives us 1, take away 2, take away 8, which is also -9. Look at that, it gives us the same answer. How amazing is maths, right? How amazing is quadratics? So 2 different methods. Now, I have a preference. If it is in this style, I do the middle and plug it in. If it's a completing the square one, I do it completing the square method. But there's no harm in doing both just to check. Okay? Let's move on. Next is quadratic formula. So when do you use the quadratic formula? Oh, this question looks a bit like the last one, doesn't it? Look quite similar. However, it's got this added in. When it mentions anything to do with decimal places or sig fig, it means you cannot factorise. You will sit here all day wasting your 3 marks trying to get that into brackets because it just does not go, right? You will not get numbers multiplied to 8 and add to 4. It's not possible. It doesn't mean it's not possible though. It just means they're not whole numbers. So it's out with our intellect. So we have to do something else. So let's rub out those brackets. So if you see a trinomial equal to 0, mention decimal places, it is this formula here, which is to formula number 1 on your formula sheet. Now, I'm a bit pernickety with my class. I like them to set this out a certain way because I mark and I see where all the marks go wrong in the substitution lines. So here is what I want you to do. Please remember, it also tells you on the front of the formula sheet that this is for ax squared plus bx plus c. So basically, a stands for what's in front of your x squared, b stands for what's in front of x, and c stands for the number at the end. So I write those down. So a, there's nothing in front of the x squared, so that's just 1. B is a negative 4, and c is a negative 8. Now, while I'm here, I get you to also go work out 4ac, which is 4 times 1 times minus 8, which is negative 32. Now, when we come to do our substitution, the formula is here. Negative b means you put in the opposite of whatever you've said b is over here. So if I've said b is minus 4, we turn that to positive 4. Had b been positive, I would make it negative when I sub it in. So the opposite of whatever b is, plus or minus. Right, b squared, please do not write minus 4 squared because you run the risk of then going to your calculator and saying that that's minus 16 and messing up. We are clever enough, we're doing National 5, we should know that any number squared is positive, so why not just square b straight away? B squared is the same as 4 squared, it's 16. And then it's take away whatever our 4ac was. Oh, wait a minute, we said 4ac was a negative number. What happens there when you've got a wee double negative? It turns into a big old plus sign, okay? So, and this is all over 2 times a, so all over 2 times 1. Let's tidy this up. It gives us 4 plus and minus, the square root of 16 plus 32 is 48, all over 2. Now, had we not done that substitution right and tried to do 16 take away 32, what would have happened? You would have had a negative. Have you ever tried to square root a negative in a calculator? Because it comes up maths error, because it's not possible. If any number is, if anything squared is positive, anything square rooted, anything you square root has to be a positive number. So that's a big no that you've made a mistake. Right, from what we then do is we go split this into 2 sums. You do this calculation in your calculator twice. Once with a plus sign, one with a minus sign in there. If you've got the fraction button in your calculator, this is an absolute doddle. So first answer, doing it with a plus, gives us to 2 decimal places, please watch your rounding, gives us 5.464, so 5.46. Doing the same calculation with a negative, so 4 take away the square root of 48, all over 2, gives us negative 1.464, so 46. It's unusual that they have the same ending, doesn't always happen like that. So there are your 2 possible answers. All right, watch out for the decimal places. You don't want to do all that lovely work and then mess up on it. So my top tips for this one, take your time with substitution, write down ABC at the side. Please watch, your square root should always be a positive number. If it's not, go back and start again. You have messed up royally because you can't get any follow through marks. And then last but not least, watch your rounding. It's either sig fig or decimal places. And you don't want to do not round, right? So there's your quadratic formula. When do we use that? When it mentions decimal places. Okay, next, following on from that, I like to do the discriminant next. Some teachers do the discriminant first. So what we just described there, see that last question, we ended up with 2 answers. This describes this scenario over here. I talked about you can't square root a negative number. So that b squared minus 4ac, fancy word is a discriminant. That's the bit under the square root of your quadratic formula. For the quadratic formula to work, for you to get 2 answers, that has to be a positive number. So hence, if we go work out our discriminant and work out b squared minus 4ac, and it's positive, we will say, oh, this graph has got 2 real roots, and it looks a wee bit like the picture there. Could be a smiley face or a sad face, but it's got 2 roots, i.e. it cuts the x-axis in 2 places. If your quadratic formula doesn't work, right, so remember I said you can't square root a negative, that's this scenario here. If the formula doesn't work, it means there are no answers. It will not work. You will not get two answers. You will not get one answer. You'll get no answers. And that means it's got no real roots. And on a picture, that looks like this graph here that doesn't touch the x-axis at all. And again, it could be down here. It could be a negative one down there as well. So if your discriminant is negative, then it doesn't touch the axes at all. It's floating up or floating down low. And then the last scenario is if we get exactly 0, it means we've got what's called a one repeated real root, or one real root repeated. I changed my wording a lot. So that means that you've factorised it and you've come out with the same bracket twice over. And that's what's going on there. And I'll show you one of those in an example in a second. So how this question appears is it just says, find the nature of the roots. You do the wee discriminant substitution thing. And based on the number you come out with, you write one of these 3 statements down. And you must write the definition exactly. You must have that 2 real and distinct roots. If you don't have the word distinct, you don't get it. So let's look at, I've got 3 examples of this one, so I want to cover all my bases. So have a look at this one here. Right, this is x squared minus 6x plus 9. So if I write down my A, B, C again, A is 1, B is a number in the middle, and C is a number at the end. And then I'm going to go do my B squared minus 4AC. I don't get you to do the 4AC for some reason in this one. B squared is minus 6 squared, so it's just 36. Take away 4 times 1 times 9, which gives you 36. Take away 36, which is 0. So then you write B squared minus 4AC equals 0, so 1 repeated real root. That was the wee statement. Excuse my writing. So there's your conclusion. 2 marks. Woohoo! Brilliant. Easy marks. Now, let's illustrate what's going on there. This actually factorises. This would be x minus 3 if you were to factorise it. Notice that this just gives you x minus 3 all squared, i.e. you have a repeated root. If you were to solve that equal to 0, you would get x equals minus 3 twice, or repeated. So that's why we say it's got 1 repeated real root, because you're getting the same answer out twice. Right, let's look at my next. Some more numbers this time. So let's write down A. A is the 2, B is the 4, and C is the 5. Let's go to our substitution. B squared minus 4AC. B squared is 4 squared, so 16. Take away 4 times 2 times 5. So that is 16, take away 40, which is negative 24. The discriminant is negative. That means I couldn't square root it. The formula wouldn't work. There's no answers. So for this one, we write B squared minus 4AC is less than 0, so no real roots. You actually just get away with writing no real roots, but I like to say why, because I'm a bit fussy like that. Last one, determine the nature of this one. So bigger numbers. Oh, A is 7, B is 5, C is minus 1. B squared minus 4AC, you can already guess what this one's going to be, is 25 minus 4 times 7 times, oh, I missed out a wee minus 1. So this gives us 25. 4 times 7 times 1 is just 28. Double negative becomes a plus 28, which is 53. This time, B squared minus 4AC is positive. So my quadratic formula would work, and I would come out with 2 answers. So this has 2 real and distinct roots. Distinct just means 2 completely different answers, like minus 3.4 and 1.8. So it's got 2 real and distinct roots. I feel like I'm talking really fast in this video tonight. Nearly there, guys. I've got 3 more slides. By this point, you can switch off. What's coming next is quadratic problems. These are the least favourite thing of my pupils, but I want to shove them in anyway. By the way, everything I've shown in this video, there is individual videos looking at more depth on my YouTube channel. These are quadratic problems. These are the ones that come right at the end of the question. These are aimed at the people that are wanting like proper really good A's or 100%. What I do like about these is quite often part A is a show that. Top tip, if you can't get part A, use it for part B, because part A is just getting a trinomial equal to 0. Part B is then solving, so factorising, solving, breaking up, or factorising using the quadratic formula, which we're all good at. You don't want to lose possibly 3 marks here and 3 marks here. Part A, forget it, go do part B, but we can't forget part A, we're going to do it. Part A quite often goes back to really simple stuff from first year, like area of a rectangle, area of a triangle, or in this case, volume of a cuboid. So I'm going to say that volume of a cuboid equals L times B times H. I'm told the volume of this cuboid is 40. I'm going to go put that over this side if that's okay. My length is x, my breadth is x plus 3, and my height is 1. Now times by 1 does nothing in maths. This is the same as me just writing x bracket x plus 3 equals 40. And I don't know about you, but the minute I see brackets I want to times them out. So x squared plus 3x equals 40. Oh, wait a minute, that's looking really like this bit up here. What's the only difference? They've moved the 40 over. They've done a Beyonce on me and they've gone to the left, to the left. Honestly, I drive my class mad with that. So it means take away 40 equals 0. And then I've got to show that. So I'm feeling pretty buzzed just now. I've got 3 marks correct in the exam. So there's part A. Part B says use your answer to part A. Well, I got it. Find the breadth of the cuboid. Now, the length and the breadth is basically asking you to find x. Had they asked for the length, I'm going to find x and then add on 3. But they've asked for the breadth, so they're just asking us to find x. So let's scroll. What we're going to go do is we're actually just going to use my answer to part A. We're going to factorise it. So numbers that multiply to minus 40 and add to 3. Let's have a wee think. Numbers that multiply to 40 and add to 3. 4 and 10. 5 and 8. There I go. 5 and 8. I was panicking there for a second. So 5 and 8. It's going to be minus 5 plus 8. When you solve them, you get x equals 5. And on this one, you get x equals minus 8. Now, hold up. X was a length in my box, so this one isn't possible. So what you do is you just put one line through it and you write discard, not possible, omit, ignore, something like that. So I'm just going to write not possible. X cannot be negative in a context question. Previously, if it was just a bit of algebra with no story around it, x can be a negative number. But in this one, x can't be negative because we're talking about a length of a box. So x is 5. Now, had they asked for the breadth, let me scroll back up. Sorry, they asked for the breadth, so the breadth was 5. The length would be 5 plus 3, which was 8, and the height was 1. 5 times 8 times 1 gives me 40. So actually, I've just checked my answer back. So please, whatever you do, try part A. If you can't do it, use it for part B. It is literally factorising, breaking it up, maybe eliminating an answer. If it mentions decimal places, it could be a quadratic formula as well. I've done loads of these in another video. I quite like one, so I thought I'd shove this one in as well, just because it's a bit different. They're using it in context, just to show you different ways of what they're asking for roots. So they're talking about a rocket being launched in the air, it goes up and comes back down. It makes this lovely symmetrical shape. Next time you throw a ball in the air, look at the shape it makes. Right, so how long is a rocket in flight? That is a fancy way of asking you to get this number here. They're asking you for the roots, right? We can see one of the roots is 0. That's when you hadn't thrown it yet or set it off. How long it's in flight is basically how long it is to here. So we're asking you to find the roots. The roots mean putting the height equal to 0. We want to know when it's on the ground. So we're going to put 0 equals 8x minus x squared. If you don't like the equals 0, just shove it to the side. Now there's a common factor here of x, which leaves me 8 take away x equals 0. If I break this up, I have x equals 0, and I have 8 take away x is 0, which just becomes 8 equals x, or x equals 8. Now look at the picture. Here's my 0, here's my 8. So how long was it in flight? It was in flight for 8 seconds. Okay. Part B says, what is the maximum height of the rocket? Well, that sounds like maximum turning point to me. So we know the middle of this rocket is at 4, because between 0 and 8 is 4. So the maximum height is when x equals 4. Now, I think I've made a wee mistake in this equation. That x should have been a t. When I've typed it up, I should have put in t's. It's not the end of the world. Let me away with it, okay? So it should have been time x seconds up there. I've just noticed this one. So x is going to be 4. So we're going to plug in the number 4. So we're going to do 8 times 4, take away 4 squared. And that's going to be 32, take away 16, which is 16. So the maximum height is 16. Now I haven't mentioned units. I'm being rubbish in this question. So the maximum height is 16 units. It probably would have been meters or something. So that's a wee weird style question. Rockets don't always go down well, but break it down. They're just still going to be asking for turning points and roots, but just worded differently, which throws everybody. And this last one I threw in because I really liked it. It's a really old one. It's not got a part A show that though, but it does take you back to very basics again. We're talking about the volume of a cube and the surface area of a cube. So volume of a cube is length times width times height. So that would be 2x times 2x times 2x, which would be 8x cubed. My surface area, well, these are all squares. They would be 2x by 2x, so 1 square would be 4x squared, and I've got 6 of them, so that would be 6 times 4x squared, which is 24x squared. We're told that the volume equals the surface area, so 8x cubed equals 24x squared. We need to work out what x is. I'm going to do a Beyonce, to the left, take everything to the left. Oh look, it looks a wee bit like a quadratic, doesn't it? Is there a common factor? Yes, it is. Common factor of 8x. Oh, 8x squared leaves you with x take away 3 equals 0. So x equals 0 or x equals 3. X can't be 0, so we write not possible. Or discard or ignore whatever your teacher tells you. I like not possible. So x equals 3. That doesn't answer the question. The question wants the length of the side of the cube. So the length is 2x, so the length is 6 centimetres. I am done. This has been the longest video I've ever made, but it does cover all the quadratics and slightly different questions from my individual videos. So if you're doing a wee cramming session, here you go. Thank you so much if you've watched up until end. Hope it helps. Bye-bye.